Hello, everybody. Hello, STEM people. So today we're going to be finding out how to find the domain and the range of a graph. It's almost always will be a function, but the key is to use interval notation. This is a small thing, but something you need to be exposed to, and I expect you'll do really well on the quiz this Friday. So interval notation is, imagine the number line goes forever to the left, forever to the right, filled with an infinite amount of numbers, but we only want to grab a group of those numbers. So what we do is we just grab an interval. We cut off a spot on the left and on the right, and we say every number in this interval is a solution. And you just have to express that interval with the correct symbols. So let's do a couple of examples. And after this, I have 4 more examples that'll hopefully enlighten us here. So numbers greater than 2. What are all the numbers? How can I capture all the numbers that are greater than 2? So 2.1, 2.2, pi, 1,000, every number greater than 2. Well, on the number line, I'm beginning just past 2. And notice we have an open circle, because it doesn't include 2. Well, what interval is captured on this green line? It's beginning just past 2, and it's continuing on forever. So this is how you would write that interval notation. Parentheses, because we aren't including this endpoint, and then comma, infinity. It's going on forever to the right. You always use parentheses when you are talking about infinity, because I always like to think of it, if I asked you to put your finger on a certain number on the number line, you could put your finger on 7 and 8 and pi, you could get kind of close, but infinity is not really tangible like that. So infinity will never have a bracket, which we'll talk about in a second, but it will always have parentheses. The next idea I have is almost the same. Numbers greater than or equal to 2. So now 2 is included, and it's still the same. It's still past 2, but the only difference is 2 is now included. And to show that, you use a bracket around the number that's included. In this case, 2 is included. So I use a bracket for 2. Let's practice this. Looking at a graph. So here's a graph. And I want to find the domain and the range. This happens to be a function. Every x value produces only one y value. But what are all the possible x values? That's the domain. What are they all? You always express your intervals from the smallest number to the biggest number. Like right here, 2, of course, is smaller than infinity, so 2 comes first. So the domain, the x values, I want to go as far to the left as the graph will allow. So if I travel to the left, I go as far left as -8. -8 is as far left as I go, but look at the open circle. It doesn't include -8. It goes right up to -8. So I need parentheses. That's the first part of my interval. And then what other x values are included? Well, -7, -6, -5, 0 as an x value, 1, 2, 3, 4, all the way to 11, but not including 11 because you have another open circle. So this is the interval that expresses the domain of this function. This is not an ordered pair. So new students will think, oh, this is an ordered pair. No, 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 no. It's next to the word domain, so it's an interval. Every number between -8 and 11, but excluding those two numbers. What about the range? Well, the range is the y value. So now you need to move your head up and down. And we always start with the smallest possible value. So if I'm talking about y values, I need to look down as far down as this graph will allow me. So looking far down, it looks like it gets as low as -4, and there's no open circle there. So I can assume -4 is included. So I have a bracket, -4. But then how high does it go? How many y values, what y value is the biggest y value? Well, over in this section, it looks like +3 is the biggest y value. The graph ends here when y is positive 2, but there's a little bump here when y is positive 3. But of course, this section over here is greater than positive 3. It goes all the way up to positive 11, but it doesn't include 11 because of that open circle. So the range is everything from negative 4 all the way up to 11. It includes negative 4, but it excludes 11. And so this is the correct interval. Pause the video right now and see if you can find the domain and range of this. Hopefully you participated and paused. Let's take a look. The domain is the x value. So I start with the smallest number. So I go as far to the left as possible. And the smallest x value is negative 4. And there's a closed circle, so it includes negative 4. And it goes all the way to the right to positive 8. And it includes positive 8. So the domain is every x value between negative 4 and positive 8. But it includes those endpoints. It includes negative 4 and negative 8. So you have brackets around both negative 4 and positive 8. The range is the y value, so I pick my smallest possible y value, which in this case is 0. There's a y value of 0 right here and here. Doesn't matter, it's the same difference. 0 is the smallest range value, and it's included. What's the largest range value? It looks like it's positive 5. The function hits positive 5 here and over here. So every y value between 0 and 5 are represented on this function. 2 more to go. Pause the video and guess what the domain and the range is here. Don't worry if you're wrong. If you're trying on your own, you're going to get better faster. I hope you paused. And the domain, well, this is what's called a piecewise function. There's no natural function that looks like this. This is 3 pieces kind of stuck together. 1 line, 2 line, and then 3 lines kind of stitched together. But we can tackle this. The domain is the set of all x values. Well, notice how it's what we call, say it's continuous. If I were to draw a pencil, use a pencil to draw this, I could draw this complete graph without ever lifting up my pencil. So that's continuous. There's no gaps. So how far to the left? What's my smallest x value? Well, this arrow is going to the left, I can assume forever. So the x values go to the left forever, which means what? It begins with negative infinity, parentheses. Infinity always has parentheses. And it goes to the right, to the right, to the right, and then there's another arrow here indicating it's going to the right forever again. So it's going to the right forever, comma, infinity. So the domain of this function is every single real number. Every real number is in this function. What about the range? Well, the range is the y value. So I look down. How far down do I go? Well, this portion of the graph only goes down to negative 2. But there's an arrow over here that's also part of the graph, and it also is going down. And I can assume it's going down forever. That's what that arrow tells me. So the smallest range value is also negative infinity. This graph just goes down forever. And what about the largest y value? Well, there's a large y value right here. You would call that a relative maximum of 4. But there's an arrow right here indicating that it's going up past 4, all the way up to infinity. So the range is also negative infinity to infinity. Last one. Pause the video. Try to find the domain and range of this function. I hope you paused. Now the domain is the x value. And you want to start with the smallest possible x value. So you're going far to the left, as far left as possible. And you're talking about this right here. And what is that x value? Negative 4. It's an ordered pair, negative 4, negative 3, but I'm concerned about the x value because that's the domain. And negative 4 is the smallest x value, and it's a closed circle, so it's included. Bracket, negative 4. Now, how far to the right? Now, this one's not continuous. If I gave you a pencil and asked you to draw this, you could not draw this without lifting up your pencil. You could draw this part, And then you'd have to lift up your pencil to draw this part. So it's not continuous. But what is the domain? What are the set of all the x values? All these x values are included, beginning with -4, -3, -2, -1. 0 is an x value, 1 is an x value, 2 is an x value. Is 3 an x value of this function? Yes, it is. It's not accounted for here because there's an open circle, but 3 is accounted for here, and everything between 3 and 4. So even though this function is broken up into two pieces, the domain is simply from every number between -4 and 4. Every number between -4 and 4 is on this function. Now, just again to repeat, when x is 3, that's on this function. It's just down at this part. When x is 2.9, it's up at this part. But every number between -4 and 4 is on this function. There's no gaps. The range, the smallest y value. Well, this has a y value of -2, and there's billions and billions of ordered pairs in just this little segment, and every single one of those ordered pairs has a y value of -2. But this y value is smaller. -3 is the smallest y value. And all the y values are included up to +2. So there you have it, domain in the range.